Welcome to this webinar, Progressing Quality Management Systems for Point of Care Testing, brought to you by SBK Healthcare and delivered by Janette Wassung, the Managing Director of Quality First Business Solutions. To see our further online material, including courses, webinars and conferences, please do visit our website www.sbk-healthcare.co.uk. Thank you. Janet is the Managing Director of Quality First Business Solutions. There she is. And it's over to you. Thanks so much.
Thank you very much, Emma and Vanessa. Thanks for the opportunity and a warm welcome to everyone. So perhaps just a short background on myself. I have a consulting, QMS consulting and training company in South Africa in Cape Town. As you can see, while the sun is shining, it's still winter here by us. So yeah, we had a very wet and long and cold winter this year, but cold for us is 11 degrees, which is probably spring for you guys. My accent as well is maybe a bit strange for you. I hope you can all understand me. My home language is Afrikaans, so English is my second language. So yeah, I've got about 23 years odd experience in quality management system. I was also on the project, one of the project leaders on the review of ISO 15189-2022 on the ISO panel, ISO committee. So yeah, we do quality management for a variety of labs, medical and non-medical, and point of care, of course, is part of the medical arena. So yeah, that's me in a nutshell. And thank you again. I hope you will enjoy this webinar. I'm going to share my screen quickly. The topic for today is progressing quality management systems for point of care. SBK has shared with me the list of registrations, where you're from, your job profile, and also what you want to learn. And lovely to have such a wide variety of job titles with us today. From the what you will learn section, I picked up quite a lot of things that would be important for you today. So that is perhaps why the presentation and the session may go slightly over time. We want to give you as much information as possible in the short period of time. Of course, this is only a 1 hour webinar, so I see there are quite a few other offerings on quality management point of care and 15189-2022 workshops later, which is more one-day sessions. So that this is really just to create some interest around the topic, to then go forward in the meantime until the other workshops arrive. Okay. A few learning objectives that I've learned from the feedback on the registrations is really it all starts with a clinical need. So really the correct instrument, correct point of care device chosen for the correct need. That's what we can start off with. Then we're going to move over point of care testing versus mainstream testing, quality control and verification. Is there a difference? So we're going to touch on a few things, processes which are possibly different between point of care and mainstream lab testing. And then lastly, we're going to look at what does ISO 15189-2022 say. As we know that the 2022 version is actively alive at UCAS as well. And we know that ISO 22870 used to be the point of care standard, and it's now been incorporated into 15189. So we're going to briefly look at a few comments on where you may want to take some notes home in regards to the new standard. Okay, so of course, the presentation starts with what is point of care, especially in line with 15189-22. I hope you guys understand what I mean if I say 15189-22. That's the abbreviated version for me. because point of care testing is now included in 15189, I have trained on the 15189 2022 version, probably about 400 participants already this year. And there's constant confusion around where do you draw the line with regards to point of care and mainstream instruments. And so I thought we would start off with the ISO and the UCAS definition for point of care testing. So if you look at the definition section in ISO 15189-22, it says examinations, point of care testing or POCT, examinations performed near or at the site of a patient. Near or at the site of a patient. So in other words, that's not really point of care devices that is used in mainstream laboratories. Those fall under 15189 anyway. If we look at what UCAS say around point of care, the definition, it says ISO 15189-2022 was published in December 22, now incorporates requirements for point of care testing when carried out in hospitals, clinics, and by healthcare organizations offering ambulatory care. So again, we can see from the definition that what is defined by point of care accreditation, ISO 15189-22, it's really not the point of care small footprint analyzers that you use in your mainstream analyzers. That, if you want those accredited, it will fall under 15189 anyway. So some goals of point of care, and I would really like you to put some questions or some discussions in the chat box. You'll see I have a couple of queries on the screen here. So the goals of point of care is really to improve the turnaround time of quality in patient care, right? We can do point of care tests at the patient's bed. We can get a result. We can get a diagnosis or a healthcare providing decision based on the result. It enhances efficiency of patient care, again, because the turnaround time is immediate and quickly. Increase physician and patient satisfaction by the fact that results are quickly available. Improve patient education because you actually work with a patient while you're doing the test. Decrease liability risk. I put a question mark there, and I would like us to think about that. There is discussions that because you do results, you do testing at the patient, you can immediately start with treatment, you can immediately treat the patient. And so the perception is that that may decrease your liability while in hospital. I would like us to question that because of things that we're going to cover today around the selection of the right device for the right result. And that is what I would like to leave with you. And then also minimize the burden at central lab level. Again, a question mark there. Do you think it really minimized the burden at central lab level? Do you think it is a plausible minimizing of burden at central lab level? What are your thoughts around that? So we know, of course, there are so many point of care tests, point of care devices out there, and it's not getting less, it's just getting more and more. The performance of many of the point of care devices and instruments that are available now is much better than 10, 15 years ago. So, which is really a great thing, that you can actually get reasonably good performance in comparison to an automated lab analyzer. So the performance is great, which is good. But as you know, there are so many choices, and where do we start to select an equipment? We also know that if you look for a point of care device that's going to do a cholesterol test for you, you can probably find about 20 to 25 different ones, different models. And how do you know which one to choose? What are they? They're all doing cholesterol testing, right? So really difficult, I think, for people that is not 100% certain which of these devices to choose for good patient care. Remember, it's all about the patient. ISO 15189-22 has two main big themes coming through. The one is it's all about the patient, and the second one is it's all about risk. So the risk to providing effective patient care, and that is no different to point of care testing as well. So there are some changes, as we know, in over the world in point of care. There's definitely an increase in bedside testing. Definitely more and more point of care facilities, hospitals are actually moving towards the development of point of care facilities and testing arenas within a hospital. We certainly see that in South Africa, and I'm sure in the UK it's no different. So there's more and more reliance from clinicians in an ER room, for example, on point of care testing and to use the results directly from a point of care device. Again, a discussion in red there. Do you think the risk is increasing? There's an increase in bedside testing. A variety of different modalities are being used now. Do you think this increases the risk to effective patient care? There's a huge variety of instruments and devices. As you've seen in the previous screen, that slide is quite old, so there's a variety of new devices currently available. There's more and more bigger point of care type instruments being utilized, what we also refer to as small footprint analyzer. And this is for me quite a dangerous and quite a gray zone area, because where do you draw the line? Is this a point of care analyzer? Is this a mainstream analyzer? Is it a mainstream analyzer with point of care technology, with a small footprint, with as I can just perhaps mention a point of care chemistry analyzer. Is the point of care version is dry chemistry, the lab automation automated lab instrument is wet chemistry. And so you get automated hematology, full blood count analyzers. This for me is a challenge that we would need to address sooner rather than later, because of the fact that it's hardly ever lab technologists and scientists that do point of care testing in hospitals. And if we're going to start utilizing or moving small footprint analyzers with actually mainstream lab technology into ERs, I think there's a bit of a gray zone there. So yeah, where do we draw the line of point of care? I take you back to ISO 15189-22 definition for point of care, which says examinations performed near or at the site of a patient. So with all the changes, quality in point of care is in the spotlight. If it isn't, it should be, because diagnoses are made from point of care results, because clinicians make decisions based on point of care devices. And I think point of care tests or point of care devices are perhaps a little bit better regulated in the UK than in South Africa, but it is still an area that I think leaves a lot of concerns, because clinicians take decisions based on a point of care result. So let's just consider a few areas of risk in point of care testing, the risk of point of care testing errors. We all know about the Theranos scandal, Elizabeth Holmes. If you don't know, go Google it. The book Bad Blood is 100% worth reading. Very, very good. Essentially, Elizabeth, tried to sell off a point of care device for anything from chemistry to immunoassays from a tiny drop of blood. And of course, that never materialized. It was all fake. It was all fraud. And she has been sentenced to jail time now, which is about 10 years after the actual scandal caught the light of everyone. Then there's also, of course, pre-analytical errors, I think, is the biggest source of errors with point of care, because it is often not laboratory people and or the people that do the testing is not efficiently trained and or competent, declared competent. So we have anything from insufficient sample, labeling errors, because often these things are not labeled, like a blood gas, it just goes through the analyzer and there's not proper labeling. Clotting of specimen is a real reality in point of care testing. Air bubbles, matrix effect, temperature, transport time, leaking during transport. So there's a variety of errors that we will need to consider when you select the appropriate point of care device. Consider these errors. What are the chances of these errors occurring with the device that you select? You will never have zero error. That is almost a given, but you need to understand what type of errors can come from your particular selected device, and can you put mechanisms in place to minimize the risk of patient harm, essentially. So the next two slides cites two studies that was done in 2009, Plebane M. 6 most cited errors in this study: failure to perform QC, not following instructions, not having trained personnel, failure to verify the calibration. Often calibrations are done automatically on point of care devices, not taking or taking ineffective corrective action for QC failures, and failure to document point of care results in patient records. Now we're moving to 2021, a study in Practical Laboratory Medicine, volume 25. Major sources of point of care errors include issues surrounding patient identification, operator competence, including non-adherence to procedure, uncontrolled reagents and equipment, inappropriate use of QC, performance of external quality assurance or PT testing performance, proper follow-up of results, and appropriate documentation. So again, understand, do some research, understand what are these sources of error in the type of point of care device that you select in your particular point of care environment where you're going to operate, who's going to operate, discuss and consider do, in other words, a whole process flow, and understand what errors can typically be avoided and or mitigated. So Quality First has developed the 5R tool for implementing a point of care and combating errors. The first R is right device selection for the right test, right patient preparation and identification, right specimen and processing, right QC performed, and right test result generated and interpreted. If you follow those 5 R's, you're probably reasonably good to go in terms of your error limitations and reducing some of the errors. So let's look now at the selection of equipment, the selection of point of care devices. Can you see the words I'm choosing there? It all starts with a clinical need. What is the clinical need? What do you want? What are the outcomes? What do you need to achieve from implementing a point of care device? What kind of results do you need? So, right device selection for the right result. Let's first understand what is the right result then. What do I mean? It means fit for purpose. Those of you that know 1518922, the word fit for purpose, intended use, is used throughout the standard quite a lot. So your right result in your particular ER room or scenario or clinician's office, do you want to make a diagnosis from this result? Is it just for monitoring of treatment purposes? Is it just a screening? Or is it anything else? What is it that you want or need to achieve? And start there with the actual clinical need. The key issue will always be what are important considerations in selecting a point of care platform. The key issue will always be, will the implementation of the point of care platform meet the clinical need? What is your needs? What are your outcomes? Will a faster result lead to a rule in or out diagnosis? Or will it change management pathways, example, appropriate referral, discharge, etc.? This is very important questions and should be weighed up with evidence-based medicine guidelines. Of course, we want to do the best for the patient. So again, it's about asking the right questions, making sure that the device is fit for purpose. So I'm going to take you through a couple of examples with, is this good enough? Fit for purpose. And these are real examples of point of care instruments that I was involved in the validation thereof. So this is good enough. HbA1c point of care. Now we know HbA1c is often used as a diagnostic tool for diabetes, as opposed to glucose, which may be a screening. So in the case of HbA1c that you want to offer, you would probably like to use it as a diagnostic tool. To be able to give an accurate diagnosis, you need good accuracy. So when you're selecting a point of care for diagnostic purposes, you want to have good accuracy as opposed to precision, which is more monitoring, i.e. day-to-day. Accuracy of diagnosis is a once-off result, and so you need accuracy. Understand the instrument specs, i.e. what is the measuring range, and look through the manufacturer validation report. What does this instrument, what can this instrument do? So just to explain, you can see on the graph on the right, I don't know, it looks like a proportional bias there, right? So I don't know if this device is good enough for as a diagnostic tool. If you look at the slope value over here, 0.89, that means there's 11% inaccuracy at certain concentrations, and you can see the linear graph on the right. Precision may be not so important, so let's focus on the slope. The correlation is fine, but you can see, I don't know if this is good enough for a diagnosis. Why the measuring range? This is often a limitation of many point-of-care devices, and in particular, probably HbA1c point of care. The measuring range is often only to about 11 or 12 units, whatever the unit is for HbA1c. But at the measuring range often do not go beyond 11 or 12. When it is with a diabetic patient, the value can be much higher. Percent, that's the unit, sorry. The value can be quite higher. Now, if you have a point of care that give you greater than 12, how can this be a diagnostic tool? How can you use this for diagnosis then? Then it's a screen. So make sure that the measuring range of the device that you choose is fit for purpose for what you want to use it for. Lipid profile point of care. So in this case, we're also looking at a diagnosis or a diagnostic tool for cardiac disease. Again, diagnosis talks about accuracy. Again, look at the measuring range and the validation data from the manufacturer. On the screen, apologies for all the little bit of reds underneath. I couldn't find the original file. But if you look at the third column, it says accuracy of this device versus LX20 is an older generation auto-analyzer in the lab, Beckman. Accuracy point of care versus the auto-analyzer. And can you see on the fourth column there is on the point of care device, venous versus capillary. Why is that important? Because in point of care specifically, you may have, you typically do a finger prick, and it may be venous or it may be capillary. You sometimes draw a blood gas and you want to use the same blood, and or you have different sample matrix between the lab and the point of care setup. So you can see from the fourth column, there's not too bad correlation between venous and capillary. Perhaps on the LDL, which is calculated, not so great, but the others don't look bad. But if you look at the accuracy of the point of care versus the lab, the auto-analyzer, and you want to diagnose a patient with a slope of 0.72, that's 28% proportional error, you need to decide, and you need to be able to live with your conscience, and you will need to be able to sleep at night if you look at these kind of results. When you're looking for diagnostic point of care devices, try not to go for a calculated measure, because a calculated measure, a calculation is always almost less sensitive than an actual measurement. So these are the things that you need to look out for. Now let's look at lipid profile again, another point of care device, another company, but this time in our clinical setting, we use it for monitoring purposes only, monitoring of treatment. So now accuracy may not be as important. We now want a good precision, repeatability monitoring. Look at the instrument specs again, the proven precision. What does the manufacturer claim the precision to be? And again, we can see here, acceptable precision is 10.5%, 2.7 for cholesterol, 3.6 for HDL. And you can see what are the actual values. Triglycerides looks fine, it's below 10.5. So that also tells you, you need to know what is an acceptable precision. What are acceptable criteria that you can use? If you look at the HDL, acceptable CV, sorry, CV is 5%, CV is 20. I'm looking at the imprecision. So 7% more or less, both on low and high values for HDL, actually doesn't look so great. So understand the outcome of the test. Here we look at a rubella IgG point of care device. So rubella, we know IgG is quite a critical test for screening purposes with pregnant women. So if you want to do a screening, like a more or less, do you just need a more or less? If the screening is positive, you would send the lady to a lab to have their ELISA or a PCR test done. If you look at the screen, there's quite a number of gray zones there. In other words, results that are positive on the one, negative on the other one, or gray zone. So there's quite a gray area, pardon the pun. But if you want to use it just as a screening, it's probably okay. I would not use this data or this particular mechanism or method for diagnostic, because there's too many gray zones there, false positives, false negatives, etc. Early detection HIV point of care. For early detection, you would need a good enough sensitivity to pick up HIV quite early. Again, we have there two sites, two studies. Doesn't look bad, 96%, 98%, perhaps it's okay, it's good enough, I don't know. But again, if this is your output, your outcome is early detection HIV, then you need to get information around the relative sensitivity of the point of care device. Excuse me. So now we look at a few concerns or a few challenges around, or differences rather, point of care versus mainstream. Laboratory autoanalyzer versus point of care devices, a few considerations. Again, this is just a few considerations. If you have to do a whole validation course on point of care, that's something completely different. So we're just going to touch base on a few considerations for you to take care of. The word, again, is fit for purpose. So on the backdrop of what we've just said, what is your outcome? What is your clinical need? Your verification, your QC that you're going to implement for point of care may vary depending on the clinical need. Okay, let me repeat that. The same as with lab analyzers, depending on the clinical need of a lab result, but I think much more so for point of care, depending on what you want from it, what you want to do with the result, your clinical need, your method validation, verification, and QC practices may vary between point of care devices. I hope you, and the reason, of course, is if it's a screening, you need less rigorous quality assurance. When it is for diagnosis, you need more. That's what I mean. Before we can introduce a new test in our laboratory, in our point of care area, we need to understand exactly what results are we going to get from it. We need to evaluate to ensure it is fit for purpose, again, depending on the clinical need. Evaluation of a method is different concept than method validation, which in turn is different than method verification. So just a sentence on that. Evaluation of an instrument means you look at the clinical need, you look at what you want from it, you look at the measuring range. So it's almost like evaluation is almost like selecting the appropriate method or the appropriate instrument. Then depending on what it is that you need, most often you only do a verification, but sometimes you need to validate because you're using a different matrix than what the manufacturer validated the device for. But so just slight difference there in application. When you evaluate a new instrument or method, you look at the entire package, pre-analytical, analytical, post-analytic. Included are what the instrument can and cannot do, logistics, complexity, costs, etc. So the evaluation of a new instrument would include all of the things that we discussed: clinical need, what are the typical error rates or errors that can occur, and can I live with this error? We're going to talk a little bit about that a little bit later. So this is quite a busy screen, selection of analyzers, but you will get the slides so you can go through it more in detail. A couple of characteristics for point of care equipment, selection characteristics for you to choose. So you could do a checklist if you want. What is your space availability or constraints? Ease of use, very important for the operators that may not necessarily have the in-depth lab knowledge. Power network requirements, critical. You want to make it as easy as possible. What are the maintenance requirements? Sample type may be important. The volume that you will need, will you be able to work with a finger prick, finger stick? Is that okay? Expiry dates, of course. Testing throughput. results comparability with local laboratory, connectivity, as we say, barcode capability, performance of the method, portability, if that is what you need. Now, important, guys, are appropriate quality control materials available? Are appropriate external quality assurance programs available? We're going to talk a little bit about this later, but perhaps just on the EQA. Point of care EQA programs are still reasonably few and far between. There's not that many service providers of point of care programs available, and you have to have point of care EQA. You can't use mainstream chemistry because the matrix is different. The whole mechanism is different. But when you decide, when you select the equipment, please first do some homework around quality control materials, either internal or external, because you may find a program, but there's only 2 labs that participate in this EQA program, which makes it null and void because there's not enough data points. Remember, for accreditation, if you want the test accredited, it will have to have a efficient, effective EQA program linked to it. And we find often that labs buy equipment without considering if there's suitable EQA programs available. Of course, the cost is a concern. Contract service requirements, what are the running costs? And of course, training is equally important. Now, let's look at method validation and verification. Let me use the word method verification, because point of care, 99% of the time, you will only verify it because it's already been validated by the manufacturer. Now, I want to put a thought into your, leave a thought with you. Don't know if you agree with me. It's okay if you don't agree with me. Method validation, quite simply put, is an error assessment. Right? Method validation is an error assessment. It is a risk assessment. You want to assess how much error there is in the method to be introduced into your lab. With that information, you want to ensure that the amount of error won't affect the result or the compromised patient care. Note, it does not say no error. The word error assessment or risk assessment means that data have to be evaluated against set criteria. So what do we mean with error assessment? If we go back to the previous screens where I ask you, is this good enough? What that you saw there are all stats. It's all told you what is the error margin that you're bringing into your lab by selecting a particular device. So that's what we mean with, there's no instrument, be that lab or point of care, that comes with 0 error, i.e. 100% accuracy, 100% very low precision, as in 0 imprecision. You will not find that. So you need to assess the risk of bringing this point of care device into your environment. And can you live with the amount of error? Again, this directly relates to your clinical need. What are you going to use the device for? So a couple of considerations around the method validation plan. Again, what is your clinical need? What outcomes do you need to achieve? Study all available literature. There's so much information available about just about on any device. Research a bit on available literature. Understand the limitations of the method, the limitations. Point of care methods also often comes with limitations which are different from lab analyzer. For example, a urine sample matrix may not work as effective on a point of care as would whole blood or plasma. So understand the limitations of the method. Take a risk-based approach, as we've just explained, and understand the clinical use of the test result. What is the result going to be used for? Now, Selection of your sample material, your material or samples that you're going to use for the verification, also some important consideration. Please at least cover your clinically relevant concentration ranges, or at least the analytical range of the method, the measuring range, or at least the normal range of your patient. So make sure that the concentrations of the sample that you select aligns with your patient population that you serve. Please make sure that you don't only select normal samples. You need a variety of between low, normal, and high. And very importantly, clinical decision limit, clinical decision concentration. Of course, there's matrix considerations that you need to consider, stability of samples, etc. Now, this again will be on your slides. I'm going to just briefly touch on it. So validation acceptance criteria could be different between point of care and lab testing. I don't know if any one of you have ever heard of the Stockholm criteria. You can Google it, you can research the Stockholm criteria draft consensus statement. What this article says is, remember we said you need, for validation, you need to have acceptance criteria, i.e., is this good enough? Understand the margin of error. So to find acceptance criteria is sometimes tricky. There's usually very generic databases available, like the Carmen-Rico's biological variation database. There's imprecision and bias databases around, but often these do not work well with point of care data because they are very aligned to lab automation. So what this article tries to achieve, it puts selection criteria into a hierarchy of where to go find acceptance criteria. Briefly explain, number one there is evaluation of the effect of analytical performance on clinical outcomes, specific clinical settings. So that's your particular clinical setting, your particular clinician settings. The clinicians tell you what they want. Number two, evaluation of the effect of analytical performance. And number 2A there is components of biological variation. As I say, there are databases available for biological variation or clinicians' opinions. Number 3, published professional recommendations from national, international expert bodies or local expert groups. So IFCC, for example, for chemistry, there's a NGSP for diabetes specific, these expert groups. Number 4, performance set, goals set by regulatory bodies. If UCAS have any particular requirements, those of you who understand CLIA in the US, those are performance goals set by a regulatory body or organizers of EQA schemes. Performance goals, i.e. clinically relevant performance goals. And number 5 is current state of the art. So there's nothing else really, and then we just go with current mean, average, as demonstrated by EQA schemes or as found in current publications. So the gist of this slide is you shall, ISO 15189, have acceptance criteria that you will use to ensure that your point of care, your verification is acceptable, the error margin is acceptable, but it now allows you to go look at other places for criteria to use. Okay, a few considerations on quality control. Again, selecting the appropriate QC material could be different from mainstream lab instrument. Fit for purpose, clinical decision limit. I want to explain this with 2 examples quickly. When you go for donation, you're going to donate blood. You at the donation center, they do a finger prick and they test your hemoglobin, right? Your HB. In South Africa, the clinical decision limit is 12.5 millimoles per liter, i.e., if your screening test is below 12.5, you may not donate blood. If it is above 12.5, you may continue and do and collect, donate blood. The 12.5 is the clinical decision limit. It is not the same as your reference values, your normal range, because a normal range for hemoglobin is whatever, between 10 and 14, right? So there's a very big difference between reference intervals and clinical decision limits. Another example, and so your QC material that you select need to cover the 12.5, because that is your clinical decision limit if you're only using a hemoglobin for that purpose. And you will need different concentrations for labs, because for a lab analyzer, because the output is different. Another example, I audited a lab the other day. They do glucose tolerance tests. They have a point of care glucometer and they screen the patient's glucose before they administer glucose powder, right? We all know what I'm talking about. So I asked the phlebotomist, what is your cutoff, your clinical decision limit, which they don't understand. So I said, what is your cutoff value? When will you not give the glucose powder? And he says around 10.5, between 10 and 11. If above that, they will not continue with the tolerance test. I said, that's great. What controls do you use to test your point of care device? And he says, okay, no, they do QC. There's a QC that comes with a kit. And I say, what's the concentration? And he says, it's about 5.8. I said, not good enough. He says, but it's a QC. I said, it's not good enough because it's not testing your clinical decision limit. Again, could be good enough for lab because 6.5 is just on the upper range of high. But in this case, it's not good enough. So select your material with a specific focus on your clinical need, on what you're going to use your point of care result for. Diagnosis, monitoring, screening, etc. Other control selection criteria, of course, the method, the type of point of care method that you're going to use, device, the method as well, whether it comes with already built-in checks, such as calibration and control mechanism that runs automatically. Your control regime may be less stringent if you have a bunch of built-in checks and calibration mechanisms in place. QC, EQA, and calibration considerations. So this is kind of what I just said in the previous slide as well. There could very well be some engineering performance, system performance controls and calibrations that happens in the background constantly. If I just think of back in my day, a blood gas analyzer had 1 point and a 2 point calibration every half an hour. There was a calibration run, and it does system checks continuously. There could be built-in QC in many point of care devices. Often the instruments self-calibrate. Sometimes a kit comes with a liquid control, external liquid internal QC before each test is run. So all of those considerations could mean that your QC regime is much less stringent than what it would be for an auto lab. Please don't forget that point of care devices are made to be robust. They're made to fall with tongue in cheek. It's made to be robust. And so your QC regime could be much less stringent. If you choose to run proficiency testing, I explained, make sure it is fit for purpose. It covers your clinical decision limit, and the matrix is not a problem, and there's enough data points. Some other considerations: training and competency tracking can be very challenging with point of care because we work with a variety of people. We often work with agency staff. And so keeping up to date with training and competency could be very challenging in a point of care setting. There could be uncertainty about pre-analytical errors, which is related to the lack of training that takes place. And the coordinator or the manager of the point of care service may not necessarily know what happens in ward H and ward G because they're not really there. And then doc control can also be a challenge because of the variety of people and the variety of settings. Could also be a bit challenging. So in conclusion then, around point of care QMS versus lab testing QMS, there's many similarities, but there are quite a number of differences. Focused on two things: fit for purpose, risk-based, clinical decision limit, 3 words actually. But at the end of the day, you would still like to sleep at night. So would your patients. So please make the right selection and implement the right quality level for your point of care so that you can sleep and your patients can sleep at night as well. Okay, the last module, I think we're okay for time. What does 15189-2022 say? We're going to quickly run through those. This screen shouts, hence the icon. The theme changes in 2022-15189. Risk management is big. Everything, every decision you make shall be based on risk, also for point of care. It's all about the patient. Have the conscious mind of always putting a patient at the end of a sample. Very big on authority and responsibilities, also for point of care. And then clinical decision limits comes through everywhere. If you have a look at 15189-22, clause 7.3, which is examination methods. If you go PDF Control F and find the word clinical decision limits, you'll find it a bunch of times. Your verification, your quality control, your measurement uncertainty, your correlation between two instruments, backup and real, all of them shall include concentrations that is aligned with clinical decision limits. Quite a big change there from the 2012 version. So just briefly, why was oh, yeah, no, this is a mistake. My apologies. Oh, goodness me, this should be, sure, 22870. Why was 22870 withdrawn? 22870, for those of you who have seen it, it's pretty much very duplicating what is in 15189. So it kind of said you shall do this plus 15189. You shall do this plus 15189. So there was a lot of duplication, a lot of need for updating references. Every time you update the one, you need to look at the other one. But the main reason is that there's an increasing number of point of care tests being performed in mainstream laboratories. We see that everywhere. The picture in the corner here is small footprint analyzers, which are more and more being used in mainstream laboratories, i.e. they fall under 15189 anyway. How does ISO 15189-22 now apply to point of care? All the clauses of 15189 apply to point of care. Now, again, I hope I have illustrated the point that while all the clauses apply to point of care, the risk is different, right? The patient care is different, the risk is different. And so your entire management system journey will be different from point of care to mainstream, yet you will be accredited to the same standard. Okay, not different. Annex A also apply. There is a slide on Annex A. And then point of care facilities, if you are a standalone point of care facility and you need to be accredited, you then need to comply to the entire 15189. So while previously your point of care facilities accreditation certificate said ISO 22870, it will now say ISO 15189-22. The scope of point of care under 15189-22, any point of care under the direct management and control of the laboratory or then standalone facilities. Now, by assumption, that means accredited point of care. If I understand UCAS correctly, point of care accreditation is not a requirement in England. It is not a requirement in South Africa either. In fact, accreditation is not is voluntary in South Africa. But so, like any other test that you can exclude from accreditation, you can exclude point of care. So, in other words, the scope under 22 is by assumption accredited point of care if you want those tests accredited. What about small footprint analyzer in bigger labs, in mainstream labs? Those will fall under 15189 anyway. And then the governing body, e.g. lab, is responsible for point of care, which means the multidisciplinary management group has been removed. Annex A, the 4 items there: general governance, quality assurance program, and training. I said earlier that quality assurance is more challenging in point of care settings, and the training program as such could also be rather challenging as such. What this means for labs: medical labs that is responsible for point of care done outside the lab will need to be compliant to 15189. And then point of care testing must be considered at the same level as other 15189 tests, other tests. As I say, the accreditation is the same, the requirements are the same, but the management system could look very differently because the risk is quite different. And so I'm closing. This is the last slide, and we're just on 2 o'clock now. A point of care prayer. What is the point of caring? A patient's life is why. Meters, strips, and testing we're sharing with non-laboratory folks who really try. Documents, texts, RTs, and nurses. Laboratory testing far and near. Often costly for hospital purses, but good for patients we hold dear. Invalid IDs, missed QC, operators oh so daring, make the job hard for you and me. So what's the point of caring? Busy nurses and cranky physicians make us lose our hair. We turn them into lab technicians at the point of care. Lord help us. Amen. That is the end of the presentation then. Thank you very much for listening to me. I hope you learned something, and my contact details are on the screen. Thank you, Emma and Vanessa. Over to you.
Oh, thank you so much, Janette. That was a really fun and nice poem, and what a nice way of ending the presentation. I've got a really sweet message that's just come in on the chat box, the question and answer box. So Jemima says, wow, fantastic to see you again, Janette. You trained me in 2012 in South Africa.
Wow, okay.
I know. She's now in Scotland as a point of care testing officer at the Glasgow Royal Infirmary. She says, it's amazing. She said, would it be possible to contact you directly?
Yes, of course, of course. You'll see that my hair has gone grey in the meantime. all good, yes, certainly.
Perfect. So Simon Wells says, our pathology point of care staff run a large proportion of EQA samples ourselves to ensure completion. Would this be deemed acceptable under UCAS standards?
Yes, it will be. Yes, absolutely. Yes.
Perfect. Thank you. Fiona asks, how would you overcome issues with finding patient samples for verification that cover the whole clinical range? For example, finding key ketone capillary samples. This was not possible for us to achieve.
Yeah, that is always a challenge. So I always advise finding old EQA samples, and the old EQA, UK-NECWAS, for example, it doesn't mean the sample is old, it means it's previously run, so there are stats available. So I would advise contact your EQA provider. They often, EQA providers make too many samples because they never know how many they're going to sell. So there's always reference material left after a cycle has been completed. There's always material left, and the beauty of that is that you will have stats available as your comparative. So that's usually a good place to start.
That's brilliant. Thanks, Janette. Just a notice to our attendees, there was a warning before Janette's presentation that we were going to overrun. Fortunately, we don't have too many questions, but please do hang on if you'd like to, and we'll be working through the questions now. Heather asks, what are your thoughts about hospital medical equipment departments managing point of care testing equipment and the effects on getting ISO accreditation? Does the lab need to keep equipment management close?
Sorry, just repeat the first part.
So what are your thoughts about hospital medical equipment departments managing point of care testing equipment and the effects on getting ISO accreditation? Okay. Does the lab need to keep equipment management close?
Probably they would. So if I understand the question correctly, it's the hospital equipment management that look at all sorts of medical equipment in the hospital, and they also oversee the point of care area and the equipment there. So absolutely, anyone can manage equipment, but if it falls under the accreditation, you would need to keep them close. You would probably need to audit them so it's almost like you're subcontracting the equipment management out. So you would need to audit them and keep them close. Yes, it will need to be part of your accreditation service, if you like. Yes.
And lastly, Lisa asks, how can quality be introduced into existing services? Many of our point of care test systems were introduced prior to the point of care team being set up. When introducing new services, we are getting much better at ensuring the verification is fit for purpose. However, we cannot update all services, and so introducing concepts such as EQA and QC, training and reassessment of competencies has been challenging.
That's always challenging. Laboratories that have run for 10 years and is accredited for 2 of those 10 years will have systems in place for the last 2 years, but historic services will not have everything in place. So my advice would be, and let me know if I'm missing the point completely, but there's always a place for saying, for example, for accreditation or for assessments, that data, verifications, instruments, people were not in compliance prior to 2018, for example, a year. And then from 2018 onwards, we now have compliance systems in place. So that's the first step, is to make sure that you have kind of a cutoff from when things are now compliant versus when they were not compliant. 2, now focus on areas that have never been in compliance or prior to management systems in place and accreditation. You would do a risk assessment on those services. In other words, if there was not an SOP in place, it's probably not a train smash. But if you use an equipment currently still today that was in effect 5 years ago, and it's quite a critical equipment, you would probably go through all the requirements and implement one by one the requirements, even though the equipment is old. Let me give you an example. we see this often. There's a requirement in the standard that says you shall have selection criteria available for equipment, and you shall measure performance, the review of performance. Equipment that have been around for years, you're certainly not going to select them again, or you're not going to have selection criteria in place because you had this instrument for 5 years. But you can now do a performance, perhaps a bit more rigorous performance review on the vendor, and start from there. Please do not tick box, please do not window dress stuff. There's no point in doing that. The other example is that we also get a lot is validations, verification, and EQA for equipment, or especially verification and validation. Prior to accreditation, this was not done. Please do not go back and verify or validate an equipment that's been proven itself over 10 years. It's working well. What you can do is summarize the past 5 years EQA feedback, the reports, summarize that and call that your verification equipment. So I would say draw a line in the sand of when systems were in place, and anything that's prior to that date, do a risk assessment on each process, on each equipment, on each area, and decide how you're going to address the compliance in a sensible, logical, value-added way. Do not tick box, do not window dress. I hope I've answered the question.
Thanks, Janet. I think so. So we've had one question slide in sneakily before we sign it off. Elizabeth has asked, and it's been responded to, so I'll read you both. So Elizabeth asked, so with this ISO 15189-2022, we do not need a multidisciplinary committee anymore. It's in the hands of the scientists. And then an anonymous attendee has responded, Elizabeth, the MDT community has been removed as a minimum requirement. It doesn't mean you don't need it anymore. The standard applies to it, so many different sizes and shapes of organizations. Having MDT committee as a requirement will not suit every customer. So many ways to comply with this standard. Is there anything that you'd like to add or respond to?
Yeah, I would absolutely agree that the standard is an international standard. If there are any regulations within a country, regulations within a hospital group that still require these multidisciplinary teams, then obviously you will need to have that. So again, it doesn't mean you don't need it, especially if it is completely separate from any laboratory. Then obviously a multidisciplinary committee will still add value. But always remember, I always say, if I can just say this quickly, an external assessor, UCAS in your case, look at 4 places of reference or they have the jurisdiction to assess you against 4 reference places. The first one is the ISO standard, which in this case is 15189-22. The second one is any country regulations. The third one is any UCAS specific requirements. And the fourth one is your own system. So there may very well be requirements outside of the ISO standard which require multidisciplinary committees still, yes.
Thank you so much. That's the end of the questions. We've had a couple of things come in the chat which have been really sweet. Our attendees have said thank you so much. You've completely answered my question. Great talk and very useful. You've got quite a few thanks coming in, which is lovely. And I'd like to thank you on behalf of SBK Healthcare. I'm so grateful for the time that you've given us today, and I hope that you've enjoyed it as much as we have.